So we were in the comparison of cyber physical systems, industrial IoT, and Internet of Things, and Industry 4.0. Okay, so in this we are just seeing what are the different applications, and is it reality or still a dream? So that's what we are been discussing. So as we have seen the smart homes, it's almost nowadays it becoming smart. That means it's becoming a reality. So not at a dream, it's a reality now. So next thing is smart cities. So smart cities still we have to do a lot of things in smart cities. So even the government of India has just planned for many cities in India. They identified to become a smart city. So there are majority of the operations are already been done or being carried out. So if you see the smart cities, so we have structural health monitoring system. So generally we call as SHM systems. So SHM system means to identify the diagnostics and prognostics of the health of the buildings. So the high-rise buildings health will be monitored. Next thing is surveillance. So we have surveillance there. Then emergency services like fire, gas leak, water leakage. So fire, gas leak, and water leakage. So in case of any water leakage or fire or any gas leakage in the city, so how that can be handled within minimal effort or minimal time. Next thing is smart parking. So smart parking now it's gearing up in many metros where you have the parking issues. So smart parking means the automated parking, or it will show you the free slot so that you can go and park your vehicle there. So something like that is smart parking. Then smart roads. So smart road means the road will guide you on assistance, and the road will give you the navigation. The roads may identify the energy energy conservation in roads. So if you deploy load cells on the speed breakers, you see load cell on the speed breakers, so they generate electricity or energy that can be used in the lights. And during the night time there will be digital displays in the roads that can assist the people to travel safely, and as well as travel to their destination in the shortest duration of time. So all these things comes under these smart roads. Then we have smart lighting as well. So smart lighting means the lights are powered by using renewable energy sources. So smart cities still many things have to be carried out. So though we are claiming our city is a very popular city, but still the city lacks basic thing, and even hygiene is also there. Sanitation, hygiene, so all these things matters a lot when you are comparing these smart cities. So many things have been already been carried out, or have been done now. So environment. So environment, I already told you a website on AQICN. So AQICN. I already showed you this website. Air quality index. So that is deployed the air quality, air pollution monitoring or air quality in all the towns in India, in all the towns and cities in India. I have already showed you that. So what is the current air quality in that particular area? Using that sensor, you can able to calculate that. That's a web interface. So you can able to calculate, or you can able to find out what is the current air quality index on that particular area, so that you can avoid traveling that area for a particular duration of time. So that is air pollution. Next thing is noise pollution monitoring. So we never bother about noise. So India is mainly the noise pollution is very high, particularly in India. But when you see Western countries, the noise will not be produced by peoples. The noise will not be exerted by public. So even right from childhood days, the people advises their kids not to make noise. So if you are in, let's say, there's a country called as Norway. So if a child is keep on crying for a longer period of time, the Norway government will take the child from the parents. So they will identify the parents do not know how to suppress them. So they will take the kid to their particular center where they will be monitoring. So this kind of things there in some of the countries. And again, noise pollution by the vehicles also it's very drastic, saying that even in Mumbai, you might have heard about 6 7 months ago or last year. In the traffic signals, some of the traffic signals they deployed. The more you honk your vehicle, the more you wait. So there was a statement. So the more you honk, the more you wait. So that means in each and every in that signal, the vehicles will be there. So usually the Mumbaians, particularly the Mumbaians, they have a habit of honking whenever they are in the signal. Okay, so whenever there are traffic signal. So to avoid that, what the Mumbai corporation have done is they deployed the noise pollution sensor there. So what it happens is when the honking is more, the timer will be increased. So if it is 30 seconds, it becomes 60 seconds. Still the honking is more, it will be 90 seconds. So only one method is all of you has to stop the honking so that you can move. The traffic will be disengaged. So that they have tested in 4 or 5 say, traffic signals in Mumbai. So maybe you may read the news there. I can put the same statement. The more you honk, the more you wait. So when you check it, you can identify which are the traffic signals they have just deployed there. So that means after that 1 or 2 days, the people identify that okay, we should not honk whenever we are in the traffic signal. So the traffic honk stops. That means the noise pollution is arrested. So only with this kind of measures, the noise pollution can be controlled in the environment. Then weather monitoring, we already have weather monitoring. It's been there for a longer period of time. Then river flood detection. So again, still maybe we can say in some places they have river flood detection, but not all the places. But during rainy seasons, we have to deploy such kind of sensors so that they can able to tell us when there is any possibility of flood. Then forest fire detection. So forest fire detection is mainly with the help of this methane gas. So methane sensors. So generally in India, away from this forest, people usually live away from the forest. But in case of any forest fire, this gas is important. There is a methane gas. So if you have methane sensor, then we can able to arrest the forest fire, or we can able to find out the any possibility of this forest fire detection. So again, some of these concepts are a reality. Some of these are still under deployment. So energy systems. So energy systems is again in some states it is implemented. So I don't know about the other states, but in Tamil Nadu the energy is smart grid is implemented. Reason being there is an integration of renewable energy also. So 10% of the electricity we get from the renewable energy. So particularly on windmills. So windmills. So in case if you are traveling towards the deep south, towards Kanyakumari, you can see around 70 to 80 kilometer stretch, there will be completely windmills only. So those windmills generate electricity that supply the demands for the entire state. So for 10% of the power supply comes from the windmills. So that means what you have to do is you have to integrate the renewable energy also into the smart grid system. So that is what the challenge here. So now if any country it crosses more than 60 percentage on the renewable energy, that will be a best country to live in. So particularly for the power generation. So they don't rely upon the conventional sources, rather they go for non-conventional. So that's how the way. But many states are still struggling. So even if you see some states in India, even basic electricity they are struggling, and the electricity bills are too costly. So it's huge, it's costly. Again, in India, Tamil Nadu is the cheapest one. They give electricity at a cheaper rate. So if you have up to 500 units you are consuming, even if your unit number of units is 499, you can pay just 830 rupees. If it is 499, if it is 501, let's say if it is 501 units, then you have to pay 2300 something. Please see that within 2 units of difference, because we have a slab of up to 500, you have to pay this much. Beyond 500, you have to pay that much. So I have stayed in Mumbai for a longer period of time. I stayed in Mumbai in almost 2 years. I stayed in Mumbai. I worked in a company. So that time we usually get 200 units of energy every month because we were bachelors. So that time, so 200 units of energy in every month. That time we paid around 1300. So think of 20 years ago, 2001 and 2002, I was in Mumbai. So I still have that bill. So because I just paid that, so I just say being an electrical engineer, I just always count the electricity bill, metering. Okay, I still remember that I paid around 1300 to 1500 rupees every month. So that's what the billing would be. So every unit of electricity is around 6.5 rupees in 2001. I don't know, maybe now what kind of thing is there, but still in some of the southern states, the electricity is very cheaper. So again, all these things it's due to the power and energy protection in the particular state. Okay, so smart grid with the renewable energy integration will be the answer for this tomorrow's problem, because now the major challenge is the fuel is costlier now. So the gasoline, like petrol and diesel, is so costlier. So people obviously going for electricity, that is electric vehicle. Obviously they are always now itself most of them they migrated towards electric vehicles, be it a car or a two-wheeler. Now we need charging stations every now and then. So again, charging station involves money there. So when you charge your vehicle for 20 minutes, you need to pay something. Now there is a rumor that if you want to consume, if you consume 1 unit of charging, then you have to pay 15 rupees. So that's what some companies are planning for charging. So that means that electricity will also be becoming too costlier. So unless we have this renewable energy integration, we cannot able to survive. So smart grids, they provide renewable energy integration also along. Apart from that, we have to have prognostic health management also. So that means we have to have the health management. The grid has to know about itself. So how much electricity is generated, how much electricity is just distributed. So those details have to be taken care by the smart grid systems. So
Sorry,
next,
sir. Sorry to
yes,
disturb. I joined late due to a connectivity error.
okay.
That's why. Just excuse me, sir. Sorry, sir.
Is it visible? The screen is visible.
Yes, sir.
Just wait, I'll share it again. Okay. Yes. So next thing is retail industry. So retail industry, indoor lighting. We have indoor lighting. Then product. So product level sensing. So if the product is been generally in shopping malls, supermarkets. So when the products have been depleted, that means once the product is have to be restocked. If the stocks are lost, so in that case, how can I restock with the help of sensors? So the sensor will monitor it and then do that. Then smart indoor lighting will be handled, and similarly smart payments. So smart payment. So now we become smarter. Now our payment is based on Google APIs. Then through WhatsApp also we can pay, and then through Paytm we can pay. So we have various payment options available in the retail industry. So retail industry again become a reality. So it's no longer a dream. So it's already been implemented, and we have something like Amazon Go. So Amazon Go, they have deployed their stores across the US in various places. So what they do is they give an app. So when you enter the store, you just show the app on a particular display or a kiosk. After that, the app identifies you are already inside the store. So once you are inside, whatever products you take it in your bag, and when you come out, it automatically bills it. It automatically bills you. So the bill will be attached to your account. So that way, the retail industry becoming very much powerful. So logistics is next option here. The logistics here is again it become a reality now, because even even last 10 years we can able to track our shippings. So whenever we book any shipping through online portals, we can able to track it with the help of this logistic management. So one is fleet tracking, shipment monitoring, and remote vehicle diagnostics. So shipment monitoring usually we can able to see, the end customers can see, but fleet tracking it's only for the companies, those who send the fleets. Okay, so fleet tracking, yes. So fleet tracking will be, they have something called as geofencing. So generally we have a concept called as geofencing. So geofencing means, yes. So geofencing means you have given an area, so you cannot cross that particular area. So that is called geofencing. So that means, So when the vehicle has to move, they will give the particular area how the vehicle has to move. So let's say if you take a local bus, so even when there is any accident in the particular road, the bus may not take an alternative route. The bus will always go in a deputed route. So that is called as geofencing. So if you are in geofencing, if you enable on your app, and if you have that map with you, then whenever you cross that particular geographical area, it will be alerting you. You are moving away from the restricted place, so go back. So something like that it will be. So one good example is the fishermen. So they have the geofencing nowadays. So fishermen. So usually fishermen, when they go beyond a particular, actually the sea, the Indian Ocean is divided by multiple countries. So if you take India and if you take Sri Lanka, so between India and Sri Lanka, the distance is just 30 kilometers from Kanyakumari and Rameshwaram to this, only 30 kilometers. So within the 30 kilometers, up to 17 kilometers, it's the ocean covers Indian border. Beyond 17 kilometers, the 13 kilometers was for the Sri Lankan government. Okay, but when they go in the boat, usually they know the area, but sometimes purposefully they may enter the particular Sri Lankan zone so that more fishes can be cultivated there. So maybe due to the reason they may go. But now the government have made a fencing also there. So whenever you cross it, you will get an alert on your mobile phone saying that you are crossing the particular fencing area. So that way you cannot move beyond this particular area. It will be an issue. So something like that they will be telling you. So these kind of applications are very much helpful for the fleet tracking also. So even you can able to control the fleets in what direction they are moving, why they are moving away from what is the defined route. So those things in logistics we can do, but logistics have become a reality. It's already been there in the industry. Reality. So next thing is agriculture. So smart irrigation, greenhouse control. So we could able to see still farmers they do not know the technicalities of the technology. Still they use the very old techniques. But some farmers they started using the technological devices for their irrigation. So that the cultivation also will be more. So the yield also will be more. So for that we can use smart irrigation by deploying soil sensor, soil moisture sensor, then chemical sensors. So many sensors are there that they can start using. And fields need carbon dioxide, human beings needs oxygen. So carbon dioxide, the availability of carbon dioxide to the fields make the plants to grow. So that is again reality. It's 50-50 we can say. So part of that we have already done it, but remaining yet to be done on this agriculture aspect. So next thing is industry. So industry, that's what our job is. This thing on industry 4.0. So in industry you can see indoor air quality monitoring. That is one. And machine diagnosis. So usually there is a knob here, so that handles the machine diagnosis. Then lighting, smart lighting here. Then emergency services, fire, gas leak, and water leakage. As we see in smart city, inside the plant also we can able to do this. And prognostic health management. So about the health of this machine, how long the machine was running, so that information, and the machine to machine communication. So M2M communication, that is also possible with this industry 4.0. So industry 4.0 again, many industries they have already migrated, but some of the industries are still lagging behind. They were in the their machining also is very old nowadays. So still they are maintaining and they are running. It is something like you are running a bullet that is launched in 1976. So still people uses one of our faculty also Chennai campus. He uses a bullet which was running in 1976. So the main thing here is the bullet. Maybe mileage, everything will be less, but still they maintain it and then they are running it. Okay. Now vehicles are becoming very smart, but those days it won't be smart. It will be tough to ride, but still they can able to do. So one major thing is we earlier days the engine was in cast iron. Now it is aluminum. So aluminum engines are so not so robust, but it's smooth. So that means it will give better mileage. But cast iron is so robust, but still now it is running even after 50 years of time. So similarly, there are many industries they are running. Their machining were in 1950s, but still they are running their industries. So again, industry 4.0 is not yet a reality, but still people has to come into it. Okay, so now when we see when we talk about the industrial system designing, so we have already we have discussed this about it, but something is new here. So the industries have to gear up for sensors. How the sensor can react, how the sensor can talk to other system components. So for that, we have some protocols, ZigBee. Then we have field bus IO, field bus protocols. So ZigBee is so common. We call ZigBee. The equivalent standard here is IEEE 802.15.4. This is the equivalent standard. So this standard they can use. So next thing is we have the sensors can talk to the gateways. So gateways are the one connected to the internet or to the cloud. So the sensors can talk to the gateways through IP protocol. Through IP. So IP in the case here we can call IPv6. It is IP version 6. Next thing is we have data structure infrastructure, we have storage, we have cloud, and we have analytics engine. So all these things will be part of the data center infrastructure. So now this is where some industries vary when compared to this. Some industries vary. So either you can have a private cloud or a public cloud, or you can go for a hybrid cloud. So in VIT Chennai and VIT Vellore we have private cloud. But some universities they go for a public cloud. Public cloud means they don't want to invest on the data center. So rather than they store all the data in the cloud, so that everything will be in the cloud. You can just maintain with the device. It's fine. So if you want administrative privileges, you will have a device or an app. Using the app, you can do everything. But private cloud means we have to manage the entire infrastructure. You might have seen there is a data center in CTS, in the first floor CTS. Inside we have a data center, which is the temperature will be maintained from 12 to 21 degrees centigrade. Any point of time, the temperature will be in this range, 12 degrees to 21 degrees centigrade. Okay. So that is what the recommended standard by the industry. So beyond 21, sometimes it goes, but we have to always pull down the servers which is already running 24/7, 365 days. Usually we never go for any maintenance. So far in the last 7 or 8 years, we didn't had any maintenance. So even during the flood during 2015, when we in Chennai when we had a flood, even that time also our servers were running. So we had the module based UPS for powering those servers. So even we don't have power connection for 3 or 4 days, but even for the 3-4 days our UPS was running. So that's what. So maintenance free data centers. Okay. So either we can go with private or we can go with public infrastructure. So then those can be accessed with the help of these IT apps. So you have an app for handling these things. Okay. So that is. And regarding the network, so network means, so what kind of networking facilities you want to use. So generally, okay, in this diagram I forgot something. Now there is something called as MPLS. So MPLS means multi-protocol label switching. So here this is MPLS. The name says this multi-protocol label switching. This is called as MPLS. So this MPLS is one kind of protocols are now mainly for manufacturing industries. Now only for companies and the factories, this protocol is been given. So it is something like a low latency and no buffering network. So let's say I am now in Chennai campus. Who are there are totally 60 students located at 60 different locations. Okay. Now we are interacting on a Google Meet. So when I put a tick, so I'm just putting a tick now. So it comes after 2-3 seconds later, the tick is there in the system there. So I just experience the delay. So the delay is, so even see now I put a dot now. So now only the entire tick is completed. So that means it is waiting for some more input to buffer it. Okay. So I can experience the delay. Let's say 2 seconds or 3 second delay is there. Maybe my voice signal doesn't have a delay, but my video has a delay. So this MPLS avoids that. So it is no latency, or the latency almost clocks 0. So that means I am here, another person in front of me from US, another person from Singapore. So all the three can able to see each other with real time, no latency, 0 latency. That means that I could able to see him right in front of me without a delay, but he might be sitting in US. So that kind of network MPLS provides. So mainly corporates, when they mainly IT in the industry 4.0, the manufacturing industry, whenever the diagnosis happening from other part of the country, other part of the world to that particular machining. These kind of networks. So actually, BSNL was providing this MPLS network in the country, but still now I think they are providing, and they have a version called as GMPLS also. MPLS, multi-protocol label switching. So it is very popular in the industry sector. Okay. But earlier we can get domestic thing also, but now it's mainly for the industry sector. Now the underlying protocols here we have is ZigBee we know, Bluetooth we know, and Wi-Fi we know. So these are the three things that we can able to use as a networking aspect. Okay. So either a canal, Ethernet, of course Ethernet. So in the laboratories, what you have used in all our laboratories, we have Ethernet. So that's why laboratories doesn't have Wi-Fi. The reason being, all the computers in the lab are Ethernet. Even I could see sometimes students they wanted to browse internet through Ethernet because it seems to be fast compared to Wi-Fi. But in industry, apart from that, we have multiple protocols called as Profinet, Modibus, and Profibus. So Profibus, Modibus, and Profinet. So these are all some of the faster networks which is available for industries particularly. But I'm not sure about what's the internal architecture of these protocols. But they are mainly their own protocols. Some industries have deployed and then they were using only for the industrial internet, so not for the outsiders. So that is on industrial systems. Then the total conceptual diagram of IIoT is, so we have device layer and proximity. So this is a networking and proximity, and these sensors they talk to the gateways. So intelligent gateway, we have gateway. Then we have service provider communication network. So service provider. So now this is where the service provider comes. So now in VIT Chennai, we have 1 gigabits per second for student bandwidth, and we have 310 Mbps for faculty internet bandwidth. So 1 gigabits per second was for the students. But Jio during the pandemic, when we had that, we were no students in the hostel, so but they were charging us. So Jio was charging us that you have to pay upfront for all the 12 months. But now later on, now they have increased to 3 months agreement. That means every 3 months we have to pay them. So that way they have just reframed the billing thing. So because many colleges, many universities, they ask for them based on that. So now here what happened? This is a service provider. The service provider gives many facilities when we go for this kind of internet connectivity there. So similarly in industries also they will be going for some service provider. So mainly from the private vendors. So then we have infrastructure platform. In that we have event processing, then security, interface, human machine interfaces, and this thing, big data and analytics. So these are the applications that are the services that we can able to do for IIoT. So then finally these applications have been used. So smart healthcare, energy, industry, factories, then smart air traffic, then again smart factories, Industry 4.0. So this is the IIoT conceptual diagram of industrial Internet of Things. Then finally we have security aspect. So in security we have API, microservices, analytics, data visualization, database integration, processing and translation correlation, inbound management, and connectivity of sensors and actuators. So the security can be ensured in all these aspects, because at any point of the any options, if there is the lapse in security, so then your system or your plant will be in trouble, or your industry will be in trouble. So API microservices, we have REST APIs. So RESTful, they simply called as RESTful API. So that is what. Analytics. So your data should be free from any errors or free from any bugs. So you have to have the analytics. Then data visualization. So nowadays visualization makes a major role called as, there is a software called as D3.js. D3. So it shows you the graphical visualization of data. So if you provide any Excel sheet based on some data, it will produce the beautiful graphical visualization. So now people want visualize the data also. So rather than writing stories, you can able to show them the visualization. Then database integration. So now databases becoming a part of life. So earlier we have mainly we have MySQL and Oracle, and we were having PostgreSQL. These are the three databases available. So now we have NoSQL, MongoDB is there. Then we have MariaDB is there. MariaDB is almost same like MySQL. So we have these kind of databases available. Now, if you take our VTop, so we run with the three databases. So one database is Oracle, another database PostgreSQL, and MongoDB is the another three databases we are using. And for Moodle, we use MariaDB. MySQL and MariaDB both. In one server, I use MySQL, other server we use MariaDB. Okay. So all these five databases we are using in our campus, and of course there are some softwares. VIT Chennai events also running with. It is also in MySQL, and we have one faculty level software. So most of the other softwares we run with MySQL. So Oracle is predominant, but the main problem here is now we are migrating everything to PostgreSQL. So whenever you upload any files to GitHub, so if you are any scanned out document, internship offer letter when you are uploading, so all these things go to MongoDB. So MongoDB is completely based on JSON script. So the entire MongoDB is on JSON script, JavaScript object notation. You know that everything in curly brace. So whatever file you upload, it will create a JSON script for that. So that is MongoDB. And PostgreSQL, so we are migrating everything to PostgreSQL. In the next 2 years, there is a plan for BTOP to be migrated completely to PostgreSQL. The reason being PostgreSQL is open source and it's completely free. So it is an enterprise level database. It's completely free, but if you want a support, you can pay some support charges and then get support charges every year 5 lakhs every year 5 lakhs. It's cheaper. But Oracle, the cost of Oracle database is starting from 70 lakhs. And even Vellore campus they purchased around 1.5 crores, but we have had for 70 lakhs we have purchased the Oracle license. So meaning that the same provision everything is handled by PostgreSQL for free. Then why should we go for this closed source alternatives? So that's why the entire world is moving towards nowadays to open source architecture. But please remember, in open source only the software is free, but the support is always pricey. Okay. Now that is on the database integration. Then processing, translation, and correlation. So processing and translation correlation. So how good is your system or how good is your client? So what way you can compare yourself with others? So those things we can able to do on the correlation. Then end node management. So inside a factory there will be multiple nodes scattered across. So how can you manage the end node management? So that is on end. Then connectivity of sensors and actuators. So this is the final. So in all these aspects, we have to enable security. So you should not leave out security in any of these layers. You should ensure security for all these layers. Else, but by some means, the attackers can include. So security means trust management, attack vulnerabilities, malwares, so even viruses. So all these things we have to counter attack these security measures. Okay. So to conclude, already we are in the era of industrial IoT era. Many factories are nowadays smart, where many functions like lathes, production lines, assembly lines, heavy machines are automated with the help of sensors. The diagnostic and prognostic measurements are handled by global distributors. Autonomous robots in factories for mission critical tasks, they have inbuilt intelligence to adapt to the environment. So most of the factories they run with autonomous robots. They can able to handle the critical tasks. So mission critical means they have a very lighter nearer deadlines so that they can handle without any hiccups or without any issues. So that's all on this comparison of this industrial 4.0, then industrial Internet of Things.